Hi guys, so this is a new video on stationary and inflection points. In this video I shall focus on problems that require us to analyze equations, and this is the second part of the video. There is an older video that deals with the same type of problems. I shall be tackling these two questions and I shall begin question 1 shortly. So question 1 came in paper 1 November 2007, question number 15. Kindly take a minute to pause the video, attempt to solve, and my explanation shall follow shortly. So we are given some data about f of x, f dash and f double dash, and we are required to sketch f of x. So let's carry out some analysis based on the given data. So the information we are given includes that from -2 to 0, f dash is negative and f double dash is positive. And I wrote this down. So f dash is negative, hence the function is decreasing, and f double dash is positive, hence I have a smiling or concave upwards curve. Now at x equals 0, I am given that f of x equals -1. So I have this point on the curve that I shall sketch. And I am given that f dash is 0, hence I have a turning point, which is why my point is in blue. If you've watched older videos, you shall remember that we used the blue color for turning points. And f double dash is positive, so the curve is still smiling. From 0 to 1, f dash is positive, hence the function is increasing. So f dash is positive and the function is increasing. F double dash is positive, hence I am still smiling. At x equals 1, y equals 2, and f double dash is 0, and I can tell that it was positive and then became negative before and after. So this is an inflection point in green, as we are used to. And finally, from 1 to 2, I know that f dash is positive but f double dash is negative. So the function is still increasing, but now after the green point I have a frown. So basically on the left hand side of the curve I have a decreasing smiling function. On the right hand side of the y-axis I have two different parts. This part has an increasing function and a smile, whereas after the inflection point I still have an increasing function but with a frown. So the function is increasing and it goes from a smile to a frown. So kind of like an S shape. Let's see how it shall look. So this is how the function should look like. On the left hand side I have a decreasing concave upwards or smiling function. On the right hand side I begin with an increasing smiling function right there, and after the inflection point I'm still increasing but with a frown or a concave downwards function. So I move from a smile to a frown at my inflection point, which is right there. This concludes our question. Take a minute to copy this down if you will. I shall begin the second question shortly. So the second question came in paper 1 May 2013, time zone 1, question 10. Kindly take a minute, pause the video, attempt to solve, and I shall begin my explanation shortly. So in question A, we are required to find f of 0 given f of x equals ln x power 4 plus 1. we simply plug 0 instead of x and we get len 0 plus 1 or len 1, which is 0. For question B, we are required to find the set of values of x for which f is increasing. So f is increasing is immediately translated into f dash is positive or f dash is greater than 0. Hence we find f dash first. We differentiate the function f, and len anything, len x becomes 1 over x. So len x power 4 plus 1 becomes 1 over x power 4 plus 1. And we multiply by the derivative of what's inside the inner function, which is x power 4 plus 1. So the derivative is 4x power 3. And I simply rewrote the function in a single fraction here. This is a simplification step. And we said before that in a fraction, if a fraction is equal to 0, then the numerator is equal to 0. Similarly, if a fraction is greater than 0, then the numerator has to be greater than 0, provided that, as is the case here, that the denominator is always positive. Since the denominator is always positive, I just need the numerator to be positive for the entire function to be positive or greater than 0. So simply I just rewrite this as 4x power 3 is greater than 0, hence x is greater than 0. So this is the solution for A and B. So for question C, we are required to find f double dash of 1. Given that this is f double dash, I simply rewrote f double dash here in green and I substituted x with 1 and I did some simplification to get a final answer of 2. In double I am told, hence show that there is no point of inflection at x equals 0. So inflection should immediately remind me that f double dash has to equal 0 at the point and has to change sign before and after the point. So we are told that f double dash of x is 0 at 3 solutions, which are 0 and positive negative 1.3. Now this tells us that f double dash of x equals 0 when x equals 0. So the first requirement is satisfied. However, in order to make sure that I have an inflection point at each of these 3 points, I have to determine the sign before and after. So I'm going to determine the sign before and after x equals 0. I've already obtained f double dash of 1. So I know what the case is after x equals 0. The case is positive, as we have here. So I just need to check how does the function look like before x equals 0. So I chose f double dash of negative 1. And when I evaluated this, I got another positive answer. So f double dash of negative 1 is positive. F double dash of positive 1 is also positive. Hence, f double dash does not change sign before and after x equals 0. So there is no inflection point. Now in question D, I am told that there is an inflection point at positive 1.3. So we have already determined that there is no inflection point at 0, and we do not know what the case is for negative and positive 1.3. But in D, I'm told that positive 1.3 is in fact an inflection point. I am asked to sketch the graph for x greater than or equal 0. So I don't care about negative 1.3. I'm going to start at x equals 0 and move forward. So in order to sketch the graph, let's summarize what we know so far about this curve. We know that when x equals 0, y equals 0. So the curve starts at the origin. So this is our first piece of information. We know that f dash of x is increasing, f dash of x is positive for x greater than 0. So the function is increasing for x greater than 0, which is my domain. So for my entire domain, I have an increasing function. So my entire sketch shall be an increasing function. We also know that f double dash of 1 is positive. So after 0, I have a concave upwards curve. And remember that I have an inflection at 1.3. So I have a smiling curve from 0 to 1.3, and I have a change at 1.3. So I expect that anything after 1.3 shall be a frown. So f double dash of 2 is negative. F double dash of anything after 1.3 shall be negative. I'm going to change from a smile into a frown at the inflection point x equals 1.3. Hence, the summary of all of this is that we shall sketch an increasing function throughout that goes from a smile to a frown at x equals 1.3. This is the requirement. And this is what the function shall look like. So as we said, we have an increasing function throughout that starts as a smile and after the inflection point becomes a frown. I've also attached the marking scheme requirements for your benefit. There are 3 marks awarded for the sketch. You want concave up left of point of inflection and concave down right of point of inflection. So basically a smile before inflection and a frown after inflection. And they've awarded another mark for a curve that passes through the origin, because we know that f of 0 equals 0, as we said before, when x is 0, y is 0, and a mark for a function that is increasing throughout, and we also said this, f dash is positive for any value greater than 0, hence the function shall always be increasing. This is what the function should look like. Take a minute to copy it down, and I shall then give you the opportunity to copy the rest of the answer down, and this shall conclude our video. So pause if you want to copy this down. And now pause again if you would like to copy any of the rest of the question down. And this concludes our second question and our entire video. I hope that you have found it useful.